Welcome to the Predictive Analytics for Marketing course. My name is Dr. Ash Pahwa, and this is lesson 2. And the title of this lesson is Data Central Tendencies and Variability. In the previous lesson, which was lesson 1, we covered the introduction to predictive analytics. The foundation of predictive analytics is statistics. So, from lesson 2 onwards, we are starting the statistics. So, we are going to follow the textbook from this lesson onwards. So, we are going to follow the textbook very closely. So, this is now lesson 2.1, which is entitled Data, Variables, and Samples. And then in the next lesson, we are going to cover displaying and summarizing data. And the lesson after that would be numerically summarizing data. So this is lesson 2.1, data, variables, and samples. This is the outline for this lesson. First of all, we are going to define statistics. Then we will define population, sample, and individuals. After that, we are going to very briefly explore inference statistics. Finally, we will define variables, sampling, and also bias in sampling. First of all, let us look into the basic definition of statistics. What is statistics? Statistics is the science of collecting, organizing, summarizing, and analyzing of information to draw conclusions. In the real world, we have lots of data, and we usually take decisions based on intuition or predisposition, or sometimes we take decisions based on the data that we may have. The analysis of such data is very important in order to arrive at the right decision. Decisions that are based on data are usually much better than those decisions which are not. Of course, the quality of the data is important. We don't want to end up with rubbish in and rubbish out scenario for our assumptions. So, legitimate statistics and samples provide a measure of confidence in our assumptions. If a decision has been taken based on the quality data, then we can say that we are 90% sure that this particular value is going to fall between these two values. Or we can possibly say that we are 95% sure that this value of certain parameters is going to fall between these two values. So then this is the goal of statistics, to provide greater confidence in the number that is being computed by statistics. Now suppose we have to define the discipline of statistics in just a few words. How would we do that? Well, whenever we use very few words to describe some discipline, we need to indicate what the goal of that particular discipline is. So, for example, if we need to describe economics, we can say this is the science about money. If we try to define accounting, it becomes this is the science of keeping track of money. In biology, it is about life sciences. In psychology, is how we think and why we do so. History, like journalism, is about who, what, where, when, and why. So, in this paradigm, if we define statistics, then we have to incorporate the concept of variation, because in the real world, we have data which varies. So, we need to understand what that variation is. The variation in real world data basically is what we call as statistics. Now the question is that why do we have data that varies? The reason is because we do not personally see everything, neither can we measure everything. We take samples, and based on those samples we make certain assessment or assumptions. But the data will be imperfect, and we have to factor that in. Statistics helps us make those assessments and shapes the decision we called upon to make. Statistics also gives us information about how much confidence we have in the assessments and any decisions we make based on them. Now let us take an example. Suppose we have this anecdotal claim that cellular telephones cause brain cancer. We need to analyze whether this particular claim is true or not. In order to do that, we need to collect data. We need to know how often and how long people are using their cell phones, whether they hold it near the ear, whether they are using a hands-free mode of some sort. Of course, we need to know whether they get brain cancer or not. So after analyzing this data, the final conclusion was there was no proven link found between cell phone usage and brain cancer. How was this conclusion reached? By using statistics. Again, if we were to rely on some individual cases and someone swears that they were using a cell phone and they got a brain cancer, the sample is not enough to arrive at that accurate assessment. We need to take an enormous amount of data. Then we have to make sure that the data represents a sufficiently broad sample, and then we analyze whether brain cancer is occurring because of the cell phones or maybe due to some other factors. So after analyzing this data, the conclusion was that no link was found between cell phone usage and brain cancer. So this is a place for statistics to help us. Now let us look into some more basic definitions. First of all, we are going to define the word population. Population means the entire group of individuals or objects to be studied. Then we have another term which is called sample. Sample is just a subset of population, and the reason why we do sampling is because it is sometimes not possible to compute the numbers for the population. Given its potential size, it would be inefficient to devote that much amount of time, effort, and resources to compute at this scale. So we just take a sample and then we measure whatever we seek from the sample, and then based on that sample data, we can make an inference. This means the particular sample has this particular kind of a characteristics. And we can say with 95% confidence that the population very likely is going to have similar kind of a characteristics. For example, if we do a polling during an election cycle, it is not possible to do or to ask everybody in the country which candidate they are going to support. So we just take a small sample of the population and then we do our projection, which is called inference, and determine what the proportion is going to be. Here we have three items. One is called population, which is the entire thing that we are trying to study. Number two is sample, a small subset of the population from which many samples have been taken to determine the proportion in the population. And the third item that we have is individual, which could be an object or it could be a person. So now let us try to understand the relationship between statistics and parameter. Statistics is the science where we study the variation in the data. It is also referred to as the numerical summary of a sample. Now suppose we have a population and then we take a sample from it. Next, suppose one of the statistics that we are going to compute is the mean, or it could be the proportion. So now in this particular image that we are looking at, we are trying to find out what is the proportion of the white respondent in the sample. As you can see, the samples total is 6 out of these individuals and 4 of them are white. So the proportion in the sample is 4 out of 6, which is 0.67. Now let us define another term which is called a parameter. Parameter is same as statistics, but parameters is defined for the population. So now suppose here we have a population, and again this population we have 25 people, and out of those 25, 15 are white. So we can say that the parameter value in the population is 15 out of 25, and that comes out to be 0.60. So that is the basic difference between statistics and parameter. Now let us define inference statistics. As I said before, the purpose of statistics is to compute some kind of information about our population. A classic example would be that if the general elections were held today, then which candidate is more likely to win? The process we would use is to take the population and some samples from it, and then in the sample itself we are going to compute the proportion. Basically, we can ask everybody in the sample whether they are going to support candidate A or candidate B. Then based on that information, we can forecast and say that if the general elections were held today, candidate A or candidate B is going to win. So based on the data that we have acquired from the sample, we can do this projection. Inferential statistics uses a method that takes the result from a sample and extends it to the population. Not only can we tell what population characteristics is going to be, but at the same time we can forecast the confidence interval. How confident we are that if general elections were held today, candidate A is going to win the election. So confidence measure also has to be computed. Now let us define the variables. There are two elements in statistics. One is constant and other one is variables. So constant are those constant numbers, just like number 5 that is commonly occurring. Now variables, as the name suggests, may be any numerical value. Consequently, the value of that particular variable can vary, and that is the reason why it's called variable. So whenever we have the data, we have certain variables associated with it. For example, if we have employee data, we have several variables such as gender, salary, which could be any number, age, which could be any number, and then we have a zip code. So here we have two types of variables. The first type is called the qualitative or the categorical variable. In the qualitative or the categorical variable, we have certain kind of categories, and only from those categories can the variable assume its value. So in a simple gender-based example, gender is the categorical variable that assumes only two values possible, which are male and female. I realize that this does not include the count that we may possibly have transgenders, but that is not the point of this exercise. We cannot perform any kind of arithmetic operation on the categorical data. So it does not make any sense to add 2 to male or add 3 to female, because we cannot perform any arithmetic. Then we have quantitative variables. Quantitative variables could be any number. Quantitative variables are salary and age, because now we can apply some arithmetic to it. We can add some numbers, we can subtract some numbers, and so on and on. Next we have zip code. Now although zip code is numerical, we cannot apply arithmetic to it. Zip codes can only assume the values from those which are already been defined as zip codes by the post office. So despite being numerical, the zip code in this particular context is a qualitative or a categorical variable. Now let us look a bit deeper into the variables. As I said in the previous slide, there are two kinds of variables. One is the qualitative and other one is the quantitative. So in the case of qualitative, these variables are only going to assume certain values from a set of given values. The qualitative or the categorical variable can also be split into 3 different parts. The first one is called dichotomous. The second one is called nominal, and the third one is called ordinal. Dichotomous means there are only 2 values. Of course, this could be male or female, or it could be present or absent, or it could be alive or dead. In the case of a nominal, no order has been associated with a group of values from which it can assume. So a classical example would be a blood type. The blood type could be A, B, AB, or O. But there is no order built into it, whereas ordinals are the categorical variable that have some order. So suppose if you want to rate pain, it could be none, or it could be mild, or it could be moderate, or it could be severe. So as you can see, there is a certain order built into it, where no pain, of course, is good. There is a little bit more pain, which is called mild. Then we have the moderate and severe. So this is an example of ordinal categorical variables. Then on the quantitative side, as I said before, these are the numerical values, and we can split them into two different parts. The first types are the counted, which are also called discrete. It means there are certain values which are associated with this data, but these values are not continuous. An example would be the total number of sick days per year, whereas the continuous quantitative variables can assume any value. Suppose we look at the blood glucose level. So the blood glucose level could be 98.6435. It can be any number that is applicable. But the total number of sick days per year are only going to be discrete in the sense that it can have a number 5 or number 7 and so on and on. But it cannot have the number of 2.3465 as a total number of sick days. So the quantitative variables can also be divided into two parts. One is called discrete, another one is called continuous. Now let us look into the concept of sampling. Sampling basically means that we have a population from which we intend to extract some information for that sample. For example, if our population has these people from number 1 to number 12, and I can pull out some of them. It could be person number 2, person number 5, person number 8, person number 10. Collectively, this becomes a sample. So now the issue that comes up is that what procedure we are going to use to pull these people out. One of the processes is selecting these people is a random number. Another way to generate a sample is that we create some kind of a protocol. For example, we can decide that every third person in our population will be a part of the sample. Another method we can use is as follows. Suppose we have a population. We can divide that population into different categories and then one element of each category and make that element as our sample. For example, suppose we are trying to create a sample for general elections. We can divide our population based on certain criteria, and one of which could be religion. So we can have Christians, we can have Buddhists, Hindus, Muslims, and various other religions. Then we can pull out a person from each religion or possibly a few people. So we can create a sample that represents all the people from all different religions. So that becomes another way by which we can do the sampling. So there are many different techniques for sampling, and each one of them have its own pros and cons. It is necessary for us to analyze the data and see what type of sampling would be best for the population in our project. So based on those criteria, we create a sample. Whenever we create a sample, we always have the concern that there could be a bias in our sample. Biases means that the true value that we are trying to represent in a sample may not exist because the sample we have taken has too many people of the same type, or it may have some other problems. So if the results of the sample are not representative of the population, then of course we can say that the sample has a bias, or we can say that the sample is tainted. So there are three types of biases. The first one is the sampling bias. This occurs because the technique used to obtain the individuals to be in the samples tend to favor only one part of the population. Now suppose we take a sample of American citizens' opinions, and suppose we select only females. That would introduce bias because we are not accommodating the opinions of males in our analysis. So this would be clearly a sampling bias. Now, the next type of a sampling bias is called non-response bias. It means that certain people are intentionally ignored or they do not provide their opinion. So when there is no response coming from them, then of course they will not be represented in the sample. So again, our sample will be biased. Now, the third kind of a bias that can exist is called the response bias, in which answer provided on the survey do not represent true feeling of the respondent. The fact is, some people lie sometimes. People may not provide correct information for a variety of reasons. This may be because they feel uncomfortable with the person who is asking the question, or the question itself may be designed in such a way as to not ask what the respondent wishes to say. So because of these factors, a bias can be generated in a sample. One of the famous examples of sampling bias led to the incorrect presidential election results in 1948. This was when President Truman was running against Thomas Dewey. The Chicago Tribune did a survey and inadvertently introduced some bias into the sample. Before the election results were official, the Tribune went to the press with the famous headline, Dewey defeats Truman. You might remember seeing this famous photo of President Truman holding up the front page of the newspaper with this very headline. It happened long time ago when these kind of techniques were very, very basic. Now, of course, we have more sophisticated to create samples and also to do the predictions. That brings us to the end of this lesson, which again is lesson 1. Let us summarize what we have covered here. We first of all defined statistics. We looked into the basic definition of population, sample, and individuals. Then we examined inference statistics. We defined our variables, which could be qualitative or quantitative. We looked at the qualitative variables, which are also called the categorical variables. Then we explored sampling issues and how a bias can taint a sample. So thank you, and I will rejoin you in lesson 2.